So good morning, and thank you for the opportunity to come over to IglooConf for a second year and to present a session over here in Finland. I think, though I haven't counted characters, my session title is a bit longer than Timu's. What I'm going to be attempting to do during these 45 minutes is to build a telemetry pipeline in Azure using Azure Event Hubs, Azure Service Bus, Azure Stream Analytics, and SignalR, and also a bit of table storage as well to store the data. A bit about myself. My name is Alan Smith. I work probably about an hour's flight away over in Stockholm as a consultant at a company called Active Solution. We've for a long time focused on building solutions using the latest Microsoft technologies, and as Microsoft rolled over and started using Azure as their main platform for developing and delivering distributed applications, we've been following that trend and building customer applications on Azure, moving customers over to Azure, taking on new customers, and exploring all the possibilities that we've got to offer in the cloud. So I write a lot of code, I do a lot of training, I deliver classroom training courses, I deliver courses to companies, I'm a plural site author as well. I'm also an Azure MVP, so I get to hang around with these guys who are sat at the tables, go to the MVP Summit and talk a lot about the latest stuff that's going on in Azure. Also, a community leader, I organise, together with my friend Magnus Mortensen, the CloudBurst conference over in Stockholm. And then a few of us, probably the guys who are looking all sleep-deprived and dishevelled over there, and Magnus, we're running something called the Global Azure Bootcamp, which is going to be running globally in a few weeks' time. And we do have a location in Finland. I'll talk about that as we go through. I really like IglooConf. I was really surprised with this bottle of champagne. Carl sent me this photo a while ago about two kinds of Formula One drivers, and I was expecting to see something with the champagne. Maybe that's coming later on. So a bit about the session, what I'm going to be talking about today. This is copy-pasted from Wikipedia talking about telemetry. And it really derives from the Latin words, meaning tele, meaning remote, and metri, meaning metering. So you're basically reading or taking readings or monitoring something remotely from a distance. This is something that I Googled around to find the definition for. I couldn't find one, so I made one up myself, talking about something called a telemetry pipeline. I've been hanging out a lot with people like Mark Sims and Dan Rosanova, who were talking yesterday, and they talk a lot about the concept of a telemetry pipeline. Putting some components together or composing some services together to build some kind of service that can take data from events, devices, whatever's going on in the world, mobile phones, applications, and be able to make sense of that data, process that data, store that data, trigger alerts on that data. So where do we use telemetry? One of the main drivers in telemetry has been game services. Halo 4 was used as the test bed for developing the Azure Service Bus Event Hubs. So a lot of the gameplay telemetry was running through Event Hubs, and a lot of the back-end services are running in Azure, processing this gaming data, telemetry data that's coming from games. For many people, it's interesting to use that data to find out how players play the game. One of the racing games, I think Forza, records telemetry data of people who are driving the game. And then they use the telemetry data of real drivers to work and build the artificial intelligence for the drivers that are driving around on the tracks. So telemetry is very useful in those game scenarios. One of the real money drivers in the Internet of Things is industrial automation. We've got these big expensive machines that are running out in factories, sometimes running in remote locations. You think about things like wind turbines. And can we monitor these devices to figure out whether they're going to break or not? Think about monitoring wind turbines. If you can detect vibrations in a wind turbine and replace a $100 part before it does $100,000 worth of damage, then it's going to be very good to look at scenarios like preventative maintenance. That's another scenario where telemetry is used. Vehicle telemetry is also becoming our big business. So being able to look at congestion, being able to look at where cars are driving, more intelligent cars and connected cars. So monitoring telemetry data, you can do things like detecting if a car's had an accident and being able to send out ambulances to the accident. Being able to monitor telemetry data from vehicles driving around, monitor the traffic conditions. So you could use, for example, telemetry data from taxis to be able to plan routes for ambulances, because taxi drivers always know the quickest way to get through traffic. You can do things like that. So there's many ways of doing telemetry processing architecture, but they all tend to follow the same pattern. We start out with an event source. The event source could be a mobile phone, it could be a car, it could be a heating system, it could be a thing if you're working with Internet of Things. It's just something that is generating what we call a stream of events, or maybe events when something occurs, some particular event occurs. We then have a process called ingestion. This is about getting the telemetry data into some kind of system where it can be processed. The ingestion services need to be very scalable. They need to be able to handle high telemetry loads. They're not concerned about processing the data. They're just concerned about get this data in from the actual device into the actual storage system. Sometimes the event sources will talk directly with the ingestion service in the cloud. Sometimes we'll have something called a field gateway, where maybe in a large factory we've got some kind of system that's ingesting data from loads and loads of sensors, and then that system is sending the data into the cloud for further processing. Different configurations we can use there. We then have some kind of processing. We want to do something with that event data, and we typically look at technologies that are good for working with complex event processing, or CEP. And within Azure, we've got a couple of choices. We've got Apache Storm, and we've got Azure Stream Analytics that we can use there. We may want to store that data once we've processed it. We've got many, many data storage services available in Azure. We've got SQL database, table storage, blob storage, Cosmos DB, as it's now called, various different models to use there, and things like SQL Data Warehouse, Data Lake, and all these kinds of data technologies that we can use. We then want to be able to analyze that data. We've got things like Power BI and various analytics tools that we can use to analyze the telemetry data. That can be analyzing live data, analyzing data from storage there. The messaging technologies I'm going to be talking about is going to be Service Bus Event Hubs. I'm going to be talking about Stream Analytics and Service Bus Brokered Messaging. I'm going to be using SignalR, but I'm not going to be talking too much about it. This is just going to be used to broadcast telemetry data out to a website, so you can basically see what's going on that website. Okay, the scenario that I'm going to be using is going to be a real-time driver tracker. If you attended the Global Azure Bootcamp last year, you may have seen that we were running with a racing game. Or if you've seen me presenting, I think most of the sessions I've presented in Finland, I've been talking about this racing game that's connected up to Azure. And so this is what we're doing. We've got the racing game, we've got people driving around on that racing game during the Global Azure Bootcamp, and you can see on the map that we've got, you may recognize yourself or somebody who you know on the actual flag. So this is actually taken from the morning of the Global Azure Bootcamp when in Helsinki they were actually running and testing the driving game. So there's 3 Finnish drivers out there on the track setting lap times. And the idea was that you can see the different flags from the world, you can see the drivers driving around on the map, and you can compete with these people. So how do we take gaming data from a game and be able to actually display that on a web page in almost real time and be able to show what's going on during the game? So this is the architecture that I'm going to be attempting to build today. Mostly the stuff is going to be hosted in Microsoft Azure. I have the game running on-premise, and I'm going to be testing the web application running on-premise. We're ingesting the data into Event Hub, and then we've got basically 2 telemetry streams. We've got one with a real-time telemetry that's going to be going out to the driver tracker, and we've got one which is going to be the telemetry archive, where the stream analytics data is going to be pushed into table storage. The reason we did that was when you go into the website, you can see your time, you can click on your actual fastest lap, and you can see the actual telemetry data, the graphs of how fast you were driving. You can also look at people who are faster than you and see when they were applying the brakes, when they were applying the accelerator, and be able to use their telemetry data to help to improve your driving style. This is hopefully going to be used in the 2018 Global Azure Bootcamp. We've got, I think it's 101 confirmed event locations, 46 pending, 147 in total. And I'm working together with these guys. We're working on doing a final push to get more locations. We do have a location in Helsinki, Finland, which looks to be somewhere in the middle of the city. So if you're interested in spending a day doing some hands-on stuff with Azure, then definitely get down to that. Are you involved with the creation of this event? Yeah, so you can speak to the organisers who are running this event. They're doing the Global Azure Bootcamp as well. It's a good day, a good way of spending a Saturday. So the Global Azure Racing Game, it's a pet project that I've been working on for a number of years, taking a sample racing game and customizing it and then using it eventually for the Global Azure Bootcamp. And I'm going to be walking through the stages of creating this. So the first thing is the event source. It started out life as a sample called XNA Racer, which is built for the XNA platform. I've spent an unhealthy amount of time customizing this and doing graphics changes, rewrites on the physics engine, all kinds of different stuff to be able to make it more playable. And then also done a lot of integration with Microsoft Azure. So the first thing we're going to look at is ingestion. How do we get the data from the actual game into the cloud so we can start processing that? And the weapon of choice here is Azure Event Hubs. So it provides a way of ingesting event data. Unlike traditional queues, it uses buffered storage to actually store the event data. So it's a slightly different mechanism to actually read the data than we would do in a traditional queue. And it is massively scalable. Whenever I speak to Dan Rosanova, he's talking about customers and the amount of messages per second. And some of the customers, it's millions of messages per second that they're throwing at event hubs to be able to process that. And it just basically handles that. You can scale it up pretty much limitlessly to handle large-scale events. Okay, to look at how the Event Hub works and what differentiates it from queues. First thing, when I talk about Event Hubs, we're dealing with events rather than dealing with messages. I kind of differentiate these. You've got a scenario where you've got something like Uber. You've got cars driving around the city and they're sending out telemetry events, which is data on whereabouts the actual Uber car is. They're also sending out messages, which is related to picking up a fare, completing a fare, a financial transaction, something that involves a billing. Now, Uber could still work if you lost 10% of the events, or even 50% of the events. You still know where the cars are roughly. It's just that the positions are being updated every 3 seconds rather than every 1 second. So with events, sometimes it's not critical that we process all of the events. With messages, we want to process all of the messages. We don't want to lose any. We don't want to even lose 1% of the actual billing requests or the transactions or the reviews that are coming in and so on. So when the events come into Event Hub, they're basically stored in something called a buffer. When we generate a reader on that, we can basically opt to start reading events off the buffer. And as the events are ingested, the reader basically has a cursor on this buffer and basically increments on. The events are not deleted. They stay present in the event buffer. And we have retention, which by default is 24 hours. If we generate a second reader, that's going to start reading on this. Instead of generating this reader at datetime.utc.now, we can say, okay, let's generate the reader yesterday or 1 hour ago or 3 hours ago. And it will basically put its cursor on the events that are stored in this event buffer, and it will continue reading these events. And hopefully, if it's got the throughput, it will catch up with the event buffer and then start reading the events in real time. So we've now got 2 readers on the Event Hub, and both of these readers are reading all of the events. If you have 2 receivers on a queue, the messages are deleted from the queue and the messages are routed to one receiver or the other. So here we have cooperating consumers rather than competing consumers. It's a slightly different pattern. So let's look at how the data is ingested. So I've got the Global Azure Racing game here. I've got the code here, which is actually sending the telemetry data. I'm actually on split screens here, so I'll drop it onto this screen. This is the code where we're actually ingesting the event data here. And we're taking this telemetry reading, which basically looks like this. And it has details on the country code, the driver. Then we've got things like the speed, the accelerator, the brakes, the driver input, the steering, the ERS battery, and things like that. Also, the X, Y, and Z positions in the 3D game world where the driver is that we can use in the driver tracker to actually display them on the game. So if I run this, what it will do is fire up the game, and it will start actually sending, when I start driving, the telemetry data into Event Hub, and we can actually start to build systems that are going to process that data as it runs through. So just drop the game onto that screen there. And I actually have a lap key from the finish event. Which I'm going to copy. And because we're in the finish event, it's given us the finish flag on the car, and I can select one of the tracks, drop in my driver name, and the data that we're seeing, the scores are stored in table storage, and all of the replay data is stored in blobs. So we're actually racing against other drivers who've competed. You can see all of that ghost data. And what that will do is, as it's running, it will basically fire off the event data into Event Hub. And if I bring up the Azure portal, we should be able to see that. So this is the resource group that I'm using for IglooConf, and within this resource group we have an Event Hub here. And if we go to the Event Hub, we can see that we've got the actual graph which is coming through, which is showing the events ingested here. So this is basically showing when I was testing, when Timu was doing his session, I did a bit of driving, and these are the events actually coming into the Event Hub. So what we've got now is the data being ingested into Event Hub. We can now think about building the downstream processing services. And we'll start to take a look at the processing section. When we think about big data, one of the challenges that we have is the data sources that we're querying get larger and larger and larger. So we have all of the different technologies like Hadoop, and we have SQL Server Data Warehouse, and we do all kinds of things like sharding. But what we're basically doing is selecting value from a static data set. This data set is having a data added to it. If it's telemetry data, data is going to be added to it. But we're really selecting these large data sets and looking at selecting our business value from that static data set. When we're dealing with event processing, what we're really interested in is selecting values from a dynamic data stream. So we really assume that the data size is infinite. And if you imagine something like Twitter, what are you interested about when you're looking at Twitter? Are you interested in about what people have said about your company, which is going to be the static data, or are you interested in what people are saying about your company, which is going to be the dynamic Twitter stream of all the data that people are tweeting in real time? So there's a lot of scenarios where we can use these dynamic data queries to be able to actually query data. Fraud detection is good. Looking at historic credit card transactions and deciding if there's a fraud. It's much more useful to look at real-time data and deciding if there's a fraudulent data taking place now. Stock trading, when we're wanting to look at the stock trading margins and figure out when is the best time to buy or sell, real-time data is best to use there. And for telemetry analysis, being able to look at mapping applications, traffic congestions based on the real-time data that's occurring. One of the technologies that we can use here is Azure Stream Analytics, which is a complex event processing technology. It allows us to query live data streams. And what makes it very accessible for developers is it uses a SQL-based query language. So if you can program in SQL, if you can query a table in SQL, you can query an event stream. The Stream Analytics is very versatile in the way that it integrates with Azure services. So with inputs, we can connect to Event Hub, we can connect to blob storage, we can also connect to the IoT Hub and get data from IoT devices. Those we can use as inputs. And then for outputs, we can go out to other messaging systems like Event Hubs, Service Bus Queues and Topics. We can also store the data in blob storage, tables, Cosmos DB, SQL Database, SQL Data Warehouse. We can also go directly to Power BI and analyze the data directly as an output from Power BI. This is what a Stream Analytics query looks like. If you understand SQL, you probably understand what's going on here. We're selecting the driver and the average speed from telemetry, which is a data stream. The thing that is slightly different is in the group by clause. I'm grouping by something called a sliding window, and I'm specifying that sliding window is 10 seconds, and also grouping by the driver. So that's going to be averaging out the speed over a 10-second sliding window, where the average speed is greater than 100 miles an hour. So if this is a real-world system, you can use this for issuing speeding tickets. If you're a car rental company monitoring telemetry data on the rental cars, you may want to issue warnings or send text messages if people are driving your cars too fast. In the gaming world, you can use this for issuing achievements. You've driven at a certain speed for a certain time, you get the gold achievement for speeding. So this is the thing that differentiates these types of queries. We've got three types of windows: sliding, tumbling, and hopping. Sliding is continuously running through the data stream, analyzing all of the time. The tumbling window, you can specify this every 10 seconds or every minute. The hopping window will give you something like the average temperature over the previous hour, and it will send out that average temperature every 5 minutes or every 10 minutes, depending on how we configure the step and the duration of the hops in that hopping window. We also need to store the data, and for the telemetry archive, I'm going to be looking at using table storage to be able to store that data and be able to push that into tables so we can actually start to read it. So let's look at how we can actually configure this using Stream Analytics and using table storage. So I'm going to jump back to the Azure portal. Within the resource group that I had, I've generated a storage account, which is called Igloo. And this Igloo storage account has a table. And that table is called Telemetry. It's an empty table. I've just created that now, and that's going to store the telemetry data for the drivers. So what I need to do is to go back to my resource group, and I've pre-created a couple of these Stream Analytics jobs. This one is called Igloo Archive that I'm going to use to archive the telemetry data. So what this is going to do is it's going to have an input and it's going to have an output. And I'm going to go and configure these here. So the inputs I'm going to configure is going to be the table storage. Sorry, the input is going to be an event hub. It's a bit challenging here. I had some IT issues, so I apologize for turning my back on you, but I'm going to select the Event Hub namespace, which is Igloo Telemetry, and I'm using the Event Hub of Telemetry, and this is going to be bringing in the data. It's already configured the security for me. I don't need to worry about that. And the format is going to be in JSON, and it's going to be UTF-8, so let's save that. I need to provide a name of this input alias. I'm going to go to the query that I've got in Word. And this is a query that I'm going to copy paste in. And what we're selecting in this query is from telemetry. That's going to be the name of the input. So I'm just copying that from Word. And I'm going to paste this into the input alias. So that means that the Event Hub will now be connected. The Stream Analytics query is now connected to that Event Hub, and it's going to start pulling the data from that Event Hub there. I'm going to need to have an output. So I'm going to go back here and go to the outputs. And the output is going to be table storage. And then it's going to have the output alias, which I think is going to be telemetry table. We need to specify in table storage a couple of things like the partition key and the row key. So the partition key is going to be how we actually group the data together. And what I'm specifying for partition key is the actual lap ID, which means that the telemetry data is going to be grouped together by the actual unique lap ID for that lap, and it's going to make it easier to actually select the telemetry data. And I think row key, I just specified row key as an actual string in the output query. So I can drop that in. And select the table name. So this is going to be Igloo, the storage account, and the table name is going to be telemetry. So click on save. So the next thing that we need to specify is the query. I've actually got this in Word, so I'm going to copy paste this into the portal. So go on to Archive and into the Query section. So that's dropping in the query there. Just a bit about this query. Because we're storing it in table storage, I'm zero padding the lap time in milliseconds in the query. So the telemetry data is going to be stored basically by the lap time in milliseconds. That's going to be the ordering of it. And then I'm also selecting various things that we can use to display in the graph. So I'm selecting the position of the car. I'm selecting the speed, the average steering, average accelerator, average ERS battery, and the lap time in milliseconds. So we can get a reading that we can use to draw graphs of the actual driver driving around the track, and that's going to be displayed on the website. So I can save this query, go back to the archive. Okay, let's ensure that we do save this. Go back to the archive, and I should be able to enable or start the job. So when we actually start the job, we've got two options. I can start it now, or I can start it at a custom time. And if I'm specifying at a custom time, it's telling me the current time in UTC, which is 9:17. I can say, well, let's start this from the telemetry data at 8:17 instead, and pick up the last hour of telemetry data. So what that will hopefully do is start the cursor at the beginning of the buffer, read in the telemetry data that I created when I was testing during a Timu session, and populate that into the table storage table. And we'll be able to go back and look at that data in the table storage table towards the end of the session. Okay, to be able to get the actual data out to the driver tracker, we're going to send it through a couple of different stages. Firstly, it's going to be going through another Stream Analytics query, and then it's going to be going out to the service bus in the form of a topic in service bus brokered messaging. So this provides what I call as enterprise class messaging functionality. We've got lots of things like dead lettering, we've got message sessions, we've got the option of message deferral, and great ways of being able to do messaging systems using the service bus. Service bus is very cost effective. So when you look at your monthly Azure bill, if you're using service bus, you typically see that the service bus costs is maybe less than a couple of dollars, and it's usually right at the bottom of the list if you sort by price. Very cost effective way of being able to process. The limitation in Service Bus using the basic tier is that it doesn't. It kind of has it kind of tops out about 2,000 message operations per second. So if you want to get hundreds of thousands of telemetry messages streaming through your telemetry pipeline, you are going to use Event Hub. But if you're working with lower message loads, I mean, 2,000 messages a second is a pretty substantial message load in many cases. But Service Bus is really built to handle up to that message load currently. Within the Service Bus namespaces, we can generate queues, which is a simple first-in, first-out queue. And we can also do publish-subscribe messaging, like we would do in BizTalk Server, using topics and subscriptions. And for the driver tracker, I'm going to be using a topic with a subscription going out for each website instance that is subscribing to the telemetry data. So if we broadcast the telemetry data into the topic, and then I have multiple subscribers, all of the subscribers will receive that telemetry data. So however many people are actually looking at the web page with the driver tracker on, each of those web applications will actually be getting a copy of the telemetry messages as they're coming through. So it's a way of broadcasting out the actual events to those sites. So, building the actual processing, the real-time processing section, I'm going to go and edit the other Stream Analytics query. So I'm going to hop out of PowerPoint, hop back into the Azure portal, and go to my second Stream Analytics query, which is going to be the Igloo tracker. So first thing I'm going to do here is configure the input. So again, I'm going to specify inputs. I'm going to add a new stream input, and this is going to be the Event Hub. It's going to be the same as I'd specified previously. I'm going to use Telemetry, I think, as the name. I'm going to make sure that I copy that correctly. And that's picked up that we're using Igloo Telemetry, the Telemetry Event Hub, and everything's good there. So that's the input configured there. The output is going to be the driver tracker, which is going to be a service bus topic. So I'm going to copy this from Word, and I'm going to go back to the outputs on this. So if I go back to Igloo tracker, outputs, let's drop on one using the service bus. Service bus topic. Output alias there is going to be driver tracker, and the service bus namespace is going to be Igloo tracker. And that has one topic, which is called driver tracker, and all of this data should be fine. And I'm going to click on save there. Now notice that I'm not writing any code. I'm just configuring how the Stream Analytics job is going to integrate with these various other Azure services. This is one of the great things about using Azure Stream Analytics. So I can go in and just dropping back to Word and selecting the query that I'm going to use. And back to the portal. So what I'm doing in Igloo Tracker is going to the query, editing the query. And dropping in the query here. Now the query is very similar to the one that I was using for the archive. One of the things that I'm doing here is grouping this by a tumbling window of 1 second. We want to get the telemetry data as accurate as possible. So I want to sample maybe 10 or 50 or 100 telemetry samples per second in the game. So we get as much precision in the telemetry as possible. However, if you're building a website with a driver tracker, you don't want to be sending out 50 events a second through SignalR to 100 clients, because that's going to break. It's not going to work properly. So what we're doing here is basically averaging this out over a 1 second time window and sending out one reading every second, which is averaging out that telemetry data. This kind of filtering is something that Stream Analytics is very, very good at. I've also got this, where lap time in milliseconds is less than 360,000, which is about 6 minutes. During the Global Azure Bootcamp, somebody in one of the events, I'm not going to mention who, basically started the racing game, drove around about a quarter of a lap and then just left it running, which meant that when you started the driver tracker, that driver was always sitting there at this particular corner during the lap the whole time. Their car was just sat there sending out this stream of telemetry data. So I actually modified the query during the day just to say that if you're parked for about 5 or 6 minutes, we're going to stop sending telemetry data out to the driver tracker, because it's just going to cause confusion to people who are actually looking at the tracker. So I actually put in that filter there just to modify that query. So I can save this query. So that should be saved. I can go back to Igloo Tracker and I can start this query. And this time I'm going to start this now. I'm not going to bother with picking up all of the archived data, all of the previous data, because that's not that relevant for the actual driver tracker itself. Okay, so let's see how we are doing in the demo. If I go back here into the storage account, into tables, yeah, I don't know if I've got the option to browse or query that table here. I'll probably have to pull it up in another interface. I'll probably do that later if I can. But what I also want to do is to see if the actual driver tracker is going to work itself. The driver tracker is basically going to use publish subscribe to actually get the messages from these subscriptions. So if I start the driver tracker in Google Chrome, it's going to fire up the driver tracker. And what it's going to do is to generate a subscription in the topic. So if I go back to the service bus topic, which was this thing here. You can see that we've got one subscription in this topic. This subscription has a globally unique identifier as its name. So what happens when you start the driver tracker? The web application starts up, and the first thing that it does is it generates a subscription in the service bus topic so it can start receiving its messages there. So what I can also do now is to stop the actual driver tracker and start another instance of the driver tracker. That's going to restart the web application again. And that should generate a second instance of the, a second subscription in here if I do a refresh. So hopefully we should now have two subscriptions present there with globally unique identifiers. One of the things you can do when you can create a subscription is there is a property called auto delete on idle, which in this instance I've set to about 5 or 10 minutes. So when the web application closes down, after a few minutes that subscription will disappear. But this is a nice way of having some kind of application that can just boot up, create its subscription, start picking up off messages, and then when we terminate the application, a few minutes later that subscription will disappear. So what I should now be able to do, hopefully, is to drive the racing game and see the telemetry data appearing in the driver tracker. This is where I always get worried during this session because there's a lot of moving parts here, and it's fairly easy that one of these moving parts can fail, especially when I'm coding at a strange angle. So I'm going to try and start the racing game and just see what happens when we run this. I'm going to copy the finish key into the clipboard. So it's going to take a while to start up because it's got to download all of the blob data from all of the actual drivers and stuff. So let's move this onto here. I'm going to start this, paste in the finish key. And I'm also going to want to have, if I can, the driver tracker somewhere in the background. I'm a bit challenged on the screen resolution here, but basically the easy track that I'm going to drive on is the track that's in green. And then you can see that we've got Alan appearing on the driver track, and you can see that we've got the finish flag on there. It did appear briefly. It's disappeared. I'm going to just test this again because that was a bit worrying. I'll just restart the driver tracker to make sure I've got the correct instance running. Yeah, I don't know if we're getting connection issues. It appears to be not appearing on here again, which is a bit strange. But we did actually see it appearing briefly on that. Typically, this demo does usually work, but we did see that it was appearing there briefly. I'm not sure if there's any issues that are breaking this. So we can also look at the event data that we've got in storage. What I need to do is to connect to the storage account to do this. So we can just look and see if we've got any data going in there. What we should be able to do is diagnose the events that are coming into the Stream Analytics job. So if I go back to the Stream Analytics job, if I look at the Igloo archive, we should see that we've got some data that actually has been running through that query there. So we are actually hopefully processing data on there. If I go back to the storage account and we look at the access keys and get the storage account name and the primary access key, I should be able to connect to that storage account and access the data. So I've got a tool which is the Azure Management Studio, which should be able to show us that. So I'm just going to configure this to connect on here. And I'm going to need the storage account key, which is this thing here. So this is the Igloo storage account, and you can see that we've got the actual telemetry data coming through here. So just looking at the archive has been working fine, bringing in those laps here. So when in the query I was specifying the lap ID being the partition key, you can see that this is the actual globally unique identifier I'm using here. We've got the lap time in milliseconds coming through, the actual timestamp when the data was stored. And then we've got the actual data coming through about the driver input, the accelerator being at 1, and this is like a sort of a 0 to 1 decimal value, the brakes that we're using, and various information about where the actual driver is during the actual telemetry, during the actual lap. So you can use that to actually monitor the telemetry data in quite a bit of detail. So back to the slides. This is pretty much what I've built during the session. It's normally an hour session, so I did pre-create the resources in the storage account. Normally I just create them from scratch, but being 45 minutes, I use pre-created resources. I got the real-time telemetry almost working. You saw that it was working for a couple of seconds. We need to go in and troubleshoot why that wasn't working successfully. But during the Global Azure Bootcamp, we had sometimes about 50 cars, 50 drivers driving around, and it was working fine, displaying the telemetry data on that. I had the archive working, taking the Stream Analytics query and sticking the stuff into table storage so it can be available in graphs. The thing that impresses me about this technology stack is that I have not written any C# code here. I haven't deployed any processes. And if you're in scenarios where you're saying, well, how do I get stuff from an event hub and stick it into SQL? You start thinking about, should I build a web job or should I start working with Azure Functions? We've got things like Azure Functions that can be triggered from event hubs. We've got things like, logic apps that can be triggered from event hubs. Stream Analytics is a great technology for that. We basically pay, per hour and for the actual capacity that we're using. But Stream Analytics is very, very, very scalable. And the way that you can combine these technologies together, use configuration rather than coding to be able to build this telemetry pipeline, which is almost code-free, and be able to create it. For me, this is sort of really great technology to be working with, really productive technology. So a bit about the analytics stuff. I'm using SignalR here to actually broadcast the data out. I'm not talking too much about SignalR because it's not really an Azure technology. But what the SignalR is doing is in the web application, we generate a SignalR hub. And for every instance of the browser, we're just basically pushing out the events to SignalR. So I've got two kinds of event broadcasting. I've got the topics and subscriptions. The topics broadcasts the events to all of the actual instances of the driver tracker application. And then the driver application broadcasts the telemetry out to all of its viewers. And during the Global Azure Bootcamp, it was a hands-on lab to actually build your own driver tracker application that connects and creates its own subscription. So your event can basically see the information running around in Azure. So I think I'm out of time. Final recommendations are check out these technologies. Take a look at event hubs, take a look at Stream Analytics. I would really highly recommend, if you have not taken a look at it yet, looking at the Service Bus brokered messaging. If you check out Pluralsight, I've done courses on Service Bus brokered messaging and Stream Analytics that you can check out. And there is, in the pipeline, somebody is doing a Service Bus Event Hubs course, which is hopefully going to be out soon. Thanks very much for listening, and thanks very much to the organisation team at IglooConf for putting on such a great event. I'll be around for questions if anybody wants to talk more about these technologies. Thank you.